A remote corner of Siberia, an ordinary morning, then without warning the sky erupts. It is June the 30th, 1908. An explosion many times more powerful than a modern nuclear weapon rips through the atmosphere. Trees flatten for miles around. Buildings shake hundreds of kilometers away, yet when scientists arrive years later they find no impact crater. This is the enduring paradox of the Tunguska event. It's a cosmic mystery that continues to intrigue us. It also challenges our understanding of Earth's encounters with space. Imagine the morning light. Suddenly, a brilliant blue orb nearly as bright as the sun streaks across the sky, leaving a thin, ethereal trail. Eyewitnesses, mostly Evenki natives and Russian settlers, describe a flash, and then a towering pillar of fire that casts a crimson glow across the landscape. One man, sitting by his house, feels a heat so intense he thinks his shirt is ablaze. The sky seems to split. Another account describes being shoved awake by a whistling wind. Then they heard trees falling and branches on fire. The sky illuminated as if a second sun had appeared. Multiple thunderclaps followed, shaking the very ground. The sheer force of the Tunguska event defies easy comprehension. Over 2,150 square kilometers of dense Siberian forest, an area roughly the size of a major city, simply vanishes. 80 million trees were felled in a radial pattern with their trunks pointing away from an invisible epicenter. Seismic stations across Eurasia registered the tremor. Atmospheric pressure waves circled the globe, detected as far away as Washington, District of Columbia. The night skies over Asia and Europe glowed for days afterward. It was a bizarre, sustained twilight. This was perhaps from light scattering through high-altitude ice particles generated by the blast itself. For decades, the central puzzle remains: where is the crater? A blast of this magnitude, estimated to be between 3 and 50 megatons, should leave an undeniable mark, a massive hole in the Earth. Yet initial expeditions find none. The absence of a conventional impact site fuels wild theories, from alien visitations to miniature black holes. Scientists, however, seek a more grounded explanation. They want one that aligns with the observed devastation but also accounts for the missing physical evidence. It is Russian mineralogist Leonid Kulik who first leads serious scientific expeditions to the remote site, starting in 1927. He expects to find meteoric iron but instead discovers a vast, charred landscape. At the blast's heart, trees stand strangely upright, stripped bare, resembling telephone poles. Farther out, they lie flattened, fanning out like a gigantic burnt butterfly. Kulik also notes peculiar pothole bogs. Initially, he believes them to be small craters, but he later excavates one and finds an old tree stump, ruling out that possibility. The prevailing scientific consensus points to a meteor airburst. Unlike a ground impact that creates a crater, this scenario involves a cosmic object exploding high in the atmosphere. Traveling at immense speeds, perhaps 27 kilometers per second, the incoming asteroid or comet compresses the air in front of it, generating immense ram pressure and heat. At a critical altitude, the body's structural integrity fails and it disintegrates violently, converting its immense kinetic energy into a colossal airwave. This explains the radial treefall pattern and the lack of a crater, as the energy is dispersed before reaching the surface. The debate over the cosmic object's identity, asteroid or comet, persists. Early proponents argue for comet, suggesting its icy, volatile composition would explain its complete disintegration and the lingering skyglow. Others contend the evidence favors a dense, rocky asteroid, citing its seemingly intact penetration into the lower atmosphere. Later studies find microscopic spheres with extraterrestrial chemical signatures in the soil and tree resin, typically associated with rocky meteorites. However, even then, the lack of significant remnants still poses a challenge for the asteroid hypothesis. A particularly intriguing, though debated, theory suggests a fragment might have survived to form Lake Chico. This is an almost perfectly circular lake located about 8 kilometers from the blast epicenter. Italian researchers propose it's a unique impact crater, citing its conical shape and magnetic anomalies suggesting a buried object. They even point to changes in peat bog sedimentation and pollen records around 1908. Yet Russian scientists counter, arguing the lake is far older based on more recent sediment analysis, suggesting its origins predate the Tunguska event by centuries. While the specific details of Tunguska remain a subject of ongoing research, the event serves as a stark reminder of our planet's cosmic vulnerability. Modern instrumentation now routinely detects smaller asteroid airbursts. An example is the 500-kiloton Chelyabinsk meteor in 2013, which shattered windows across a Russian city. These events, which happen once every few hundred to 1,000 years for Tunguska-sized impacts, highlight the dynamic nature of our solar system. They also show the quiet vigilance of scientists seeking to understand Earth's place within it. The Tunguska event, a blast 1,000 nukes strong with no crater, pushes the boundaries of scientific inquiry. It is a story of a silent sky turning into a cataclysmic inferno of human terror and scientific persistence. The mystery endures, a compelling narrative of Earth's ongoing dance with the cosmos.